A vocabulary term you may need to know is the word variable. A variable is any unknown number that's usually represented by a letter. So in this equation, 13 plus n equals 21, the n is our variable. It just means that it's a holder for a number, and we have to figure out what number to put in there. Now when you're solving a problem like this, there's some things that you can do to help you. I start by visualizing this as a giant teeter-totter, and I always put the teeter-totter balance right here on the equal sign. Now if you know anything about teeter-totters, you know that on a teeter-totter, to make it work correctly, each side needs to be balanced. So if this is Bill and Bob, when Bill and Bob sit together, they should balance out with Joe. Now to help me, I can visualize this with some tallies. On this side right here, I know that I have 21, so I can draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So on this side, I know it's for 21. On this side, I know I have 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But I know that's not balanced. If I have 21 here and 13 here, I know I need to add some more. And that's what I'm trying to figure out, is how much more do I need to add up so that the two sides are equal, so that no one's left sitting on the ground and someone else is flying up in the air. It's balanced like a teeter-totter. Well, I have 13 so far. Let's just count on to get up to 21. 14, 15, 16, 17, 18, 19, 20, 21. Now I know the two sides are balanced. There's 21 over here, 21 over here. They truly are equal. Let's figure out what n was. 1, 2, 3, 4, 5, 6, 7, 8. So in this problem, we figured out that n must equal 8 in order for the problem to be balanced. Let's try an example with subtraction. It's the exact same procedure as before. Start by visualizing it as a balance or a teeter-totter, and really divide it up so you know the two sides. Now on this side, we know that we want to equal up to 6. 1, 2, 3, 4, 5, 6. And on this side, I know I'm starting off with 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now we know this isn't balanced. We have 6 on this side and 15 on this side. Normally, we would just add over here and then it'd be balanced, but I can't. Look, the 6 is all by itself. There's no instructions to add anything. So the only way to make these two sides balance and to make our teeter-totter work correctly is for the 15 to go on a diet. If it goes on a diet, it can lose some of these tallies, and we need to figure out how many it needs to lose in order to be balanced. So let's start taking some away. I know that it can keep 6. If there's 6 tallies on this side and 6 tallies on this side, we'll be balanced. So right here I have 5. If I add this 1 right here, I will have had a total of 6. Sorry, that red line there disappeared underneath my blue line. Now I just need to figure out how many of these guys I need to take away in order for it to be balanced. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I take away 9, then I would know I'd have 6 left here, 6 left here, it would be balanced. So we figured out that z is going to equal 9. Notice it didn't matter whether I was adding or subtracting, the strategy was the same. Start by drawing the balance beam, draw the line over the equal sign so you know the two sides. Represent with tallies any number that you do know. Once you have all your tallies for each side, decide what you need to do. If it's a subtraction problem, figure out how many you need to take away in order to keep them balanced. If it's an adding problem, figure out how many you need to add on in order to make them balanced. I have two problems that I want you to solve yourself. On a whiteboard or on a scrap piece of paper, I want you to solve each one of these problems on your own. You probably will need to pause the video so you have time to do your thinking. Once you have the correct answers you think, go ahead and start the video again so you can check your work. Go ahead and pause now. Welcome back. You must be ready to check your work. Let's think this through step by step. What's the first thing that we do? You said draw the balance beam, you would be correct. Make sure you're really clear about what is on each side. What did you do next? you said draw your tallies, I would agree. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And on this side, we don't know what R is, but we do know 7. 1, 2, 3, 4, 5, 6, 7. Now ask yourself, are those two balanced? Well, no, 11 is not the same as 7. On this side, though, I'm given permission to add on, so let's go ahead and add some more. Starting at 7, let's count up to get to 11. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now they're balanced. Both sides have 11. That means R had to equal 4 in order for me to balance the two sides. It's the same for subtraction. Start by drawing your balance beam. Make sure you clearly know what's on each side. Draw tallies for what you do know. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now ask, are they balanced? Well, no. This has 19, this has 8. That's not fair. Now, we can't add anything to this side. This side is done. That means we have to shrink the other side in order to get it down to 8. Circle what you have, that is 8. 1, 2, 3, 4, 5, 6, 7, 8. As carefully as I can, we'll circle those 8. Well, to be balanced, I can only keep these 8 with these 8. That means all the rest of these have to be taken away or deleted in order for it to be balanced. That would be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 that needed to get subtracted. If we could subtract those 11, so if G equals 11, then each side would have 8 and it would be balanced. If you got these two correct, you can go ahead and move on to your next activity.